Well, I've got into the regime that I wanted, so I now sleep nights. I wake up early, and so I have daylight for the board, and I'm giving the lecture sort of in the middle of my waking time, so I should be more awake. So hopefully, something will not come up that disturbs it. So hopefully I can stay in this regime for a long time, because it's pretty much ideal. And while I'm preparing the board and lecturing, I'm doing the pre-processing of the previous day's filming and then uploading it to YouTube. So those two tasks go on in parallel. I've learned, if you've been following me from before, never to multitask, do something else while I'm pre-processing the film with the use of Microsoft's Movie Maker. And since I made that decision and stuck to it, it's working. I've not had any problems. So hopefully things will finally settle after about 6 months. It's sort of ridiculous. Okay. So a general comment. I suppose you've noticed things are definitely getting tougher. I'd say we are now well into M1 level. Some of you, well, there's not much point saying it, because if you have dropped out, you won't be seeing this. But well, some students probably have dropped out because it is getting tougher, and therefore, if you are finding it a bit heavy going, then you'll need to concentrate, and I'll try to be as clear as I can. I do worry a bit later. You see, my strategy at the moment is that I learn as I write up the board, if it's not familiar to me before. But a lot of this stuff now is well, it's SIPS's way of doing things, and some of the proofs I've not seen before. So I am learning, and I'm learning by writing up the board. And that seems to be working at this level, but I do wonder, at some stage I'm going to get stuck as I keep rising in levels, M1, M2, PhD 1, PhD 2 levels, and so I'm probably going to have to be doing quite a bit of studying, preliminary studying, before I film one of these much higher level topics. But that's a few years away, so things will evolve quite a bit. But for the moment, it's I'd say definitely an M1 level. The proofs are getting tougher, especially the logical basis, the skeleton, the logical skeleton of the proof. If you strip away the details that come later. So I think my strategy as prof is to try to make that logical skeleton, the essence of the argument, of the logic in the proof, to make that as clear as I can, because it's often a chain of logic, many steps, and can be somewhat difficult to get your head around if it's not presented clearly. So I'll try to do that. So now this board, we'll do 2, we won't finish, but oh, another comment. Have you noticed the proofs are getting longer and hence harder? I'm not getting to complete proofs done on a board now. So I'm having to overlap a little bit just to have a certain sense of completeness. Like previous board, for about half a square or so, I was starting on the theorem that will take quite a few sessions of this board, starting on it the previous session, but I had to repeat those early lines for reasons of completeness. So it becomes a coherent whole for you. So noticing that trend also. Okay, so what were we doing? Well, earlier we're just starting on this theorem, 5.10, or 5.10, and we've been talking recently about the constrained Turing machine, constrained in the sense that the length of its tape is finite. Okay, and we showed previous board that the language A, LBA, was actually decidable, which is probably not surprising because it's so much, the capacity, memory capacity is finite and so forth. But what we'll now show is this particular language, with its corresponding problem, is actually undecidable. So we're just starting on that previous session. So we'll spend, let's see, 1, 2, 3. Oh my God, 3.5 sessions, virtually the whole board, almost the whole board, on just on this one theorem. So the theorems are getting harder, longer, and therefore demand correspondingly more concentration. So now I will, this session, try to give you the skeleton, the logical skeleton of the argument, and ask you to really put on your thinking caps and concentrate, because it's getting tougher, and the reasoning now is multi-step. There are quite a few steps in the logical reasoning, and makes it harder. All right. So the theorem statement is this particular language is undecidable. Let's translate that into computational problem form. It's probably easier to comprehend that way than this particular way that SIPSA chooses to do of translating a problem, which is more readily comprehensible, into a more abstract way of a language. But anyway, that's his style, and he's done it consistently throughout the text so far. So getting used to it. And remember, there's a close correspondence between a language and a computational problem. So here's the language. Have I defined it? Well, let me do two things. Give you the language. I should be able to do it from memory. What is it? This means empty, in effect. So this language will consist of elements. A language is just a set of elements, set of strings. So the string is an encoded description of a Turing machine, a limited Turing machine, an LBA. So here, do I have it written here? No. So I have to. So E. Yeah. Okay, so ELBA is defined as the language whose strings are an encoded description of M, okay, and M, where M is an LBA, it's one of these limited Turing machines, and the language of that LBA is the empty string. And in other words, it's the set of all LBAs whose language, each machine's corresponding language, is the empty set. In other words, the language doesn't accept any strings. Okay? Now that particular language is undecidable. Now that's in language format. Now let's do it in terms of computational problem format. What does that mean? And if it's undecidable, that means there is no Turing machine, and normal Turing machine. No infinite tape Turing machine. So there's no normal Turing machine that can give you a decision, yes or no, whether a random LBA, just any old finite length taped Turing machine will accept hold on. Whether that LBA will accept no strings. Alright, hope that's clear. Okay, so how to go. So the proof idea, gone. Two whole sessions, right? Just the idea, the proof idea, and the actual proof itself. I was saying like 3.5 sessions. So we have 7 squares, 7/8 of the board on this one theorem, 5.10. Okay, so that seems to be the pattern. No, yeah, things are getting tougher. Right, so the proof idea. Again, a bit of revision. Nearly all, I think all, so far all. Not too sure about the future, but so far all these kinds of undecidability proofs have used the very broad proof strategy or proof method of proof by contradiction. Okay, and again this one no exception. And in the last square